Hello, here we have a contingency table for pets for single-family pet owners, and it basically shows males and females differing preferences for pets. So we went out and gathered some data about males, how many pets or what types of pets and how many of them males and females have. Like males have a certain number of dogs, a certain number of males had dogs, a certain number of males had cats, and a certain number of males had bats. And we did the same thing for females. And we gathered this table. It's called a contingency table, and these individual boxes here are called cells. The vertical element of the table are called columns, and the horizontal element of the table are called rows. So now we came up with this contingency table is what it's called, and now we are going to answer some questions on the table. And to answer these questions, we first have to get the row and column totals. So let's get the row and column totals. So let's start with the column totals. To find the row and column totals, it's best to use a calculator. Alright, for dogs, 180 men had dogs and 198 females had dogs, which total 378 people who were surveyed had dogs. Alright, cats, 92 plus 129 is equal to 221 total surveyed had cats. Bats, 3 plus 2 is 5, had bats. Then up over here, I can do the column totals. So, how many males were studied? Well, 180 males had dogs. We're just going to assume here that each person has only one pet. Like you can't have a dog and a cat, because otherwise this wouldn't make sense. But so 180 males had dogs, 92 males had cats, and 3 had bats. Okay, so it's 275. Now let's figure out how many females we've studied. So 198 plus 129 plus 2, 329. Alright, now for the grand total. To make sure we did things right. Alright, so let's sum up how many males we studied plus how many females we studied, which is 604. And now the other side should also equal that number. 378 plus 221 plus 5 is also 604, so we know this total is right. Alright, now we can answer the questions now that we have these row and column totals. Okay, find the marginal distribution of pets. When I think of margins, or marginal distributions, I think of margins. We just found the margin totals. So now all we're asked to do is to use those margin totals and find the distribution. So, to find the marginal distribution of pets, I'm going to construct a frequency table here. I'll do it horizontally. And so, one row will be labeled pets, and the other row, percent of those we studied. Okay, so what percent of people had dogs, cats, and bats? Well, dogs, 378 people we surveyed had dogs. You know, percent is part over whole times 100, so the part is 378. The whole is everybody we surveyed, which is 604. Multiply that by 100, and you will get 62.6%. Now do the same for cats. 221 people we surveyed divided by the total of 604 times 100, that's 36.6. Bats, 5 divided by 604 times 100, that will give you 0.828. Okay, so that's the marginal distribution of pets. Now let's do the marginal distribution of gender. Now when you're making these little frequency tables, you can also always make them vertically. So I'm going to make this one vertically. So let's label one column gender, and the other column percent. So we have males, we have females. Now what percent of those people we studied are males? Well, the margin total for males is 275 divided by the total of everyone we surveyed is 604. That gives you 45.5%. In females, the total we surveyed are 329 divided by 604. That gives you 54.5%. Alright, and lastly we can check both these frequency tables that we constructed to make sure they equal 100. So let's make a third column here of total and add all these percents up. 62.6 plus 36.6 plus 0.828, 100%, roughly 100%. And same here, 45 plus like 55, that's 100. Alright, so we did that part of it. Here are two more questions that we can answer. Alright, find the conditional distribution of pets for the males. Okay, so conditional distribution is a little different than marginal distribution. It's the same, I mean, it's basically the marginal distribution under the condition that the question provides. So here, it's asking, of the males, what did they choose? What pets did they choose? So basically you can look at this table and just cover up females because it has nothing to do with the question. It's irrelevant. So 180 males chose dogs, 92 cats, 90 chose cats, 3 chose bats. Now what we have to do is we have to take those numbers and turn them into percents. Alright, so let's construct our frequency table. I'm going to make this one vertically as well. So pets, and now percent, but not just total percent, percent of males. And of course we have dogs, cats, and bats. Alright, now using a calculator, let's figure out the percent of the males who chose dogs. And that would be, well, 180 males chose dogs. Divide that by the total number of males, which is 275, times 100, comes out to be 65.5. Now the percent of males who chose cats. Well, 92 males chose cats, divided by 275 males there were total, times 100, and you're going to get 33.5%. Now to find the percent of males chose bats, 3 males chose bats, divided by 275 males were surveyed, times 100, you get 1.09. And last of all, the conditional distribution of gender for those who own pets. Well, I guess, I'm sorry, this question is not correctly phrased. It should be for those who owned dogs. Okay, let me move this up a little bit. Fold this sheet so you can see this. Okay. So, the conditional distribution of gender for those who own dogs. So now we're going to cover up cats, and we're going to cover up bats. We don't care about that. It's not part of the question. All we care about is, of those people who chose dogs, what gender were they? So 180 were male, and 198 were female. Now we got to get that into percents. Okay, so one column will be gender of our frequency table here for this distribution. The other table will be percent, but not just percent, percent of those who own dogs. Okay. Alright, well, there are males and there are females. To find the percent of dog owners who were male, well, we know that 180 dog owners were male divided by 378 males were surveyed times 100, and you'll get 47.6. The percent female is 198 divided by 378 times 100, and you will get 52.3. and those should come to 100 if you added them up. So that is how you do marginal and conditional distributions. Thank you for watching.